A very good morning, students. I am Azizur Rahman Ansari. Today I am presenting here your lecture number 10 of Transportation Engineering. In this lecture, we will discuss about the design of highway pavement. But before starting of this section, let us see what are the various points, what are the various contents that we will cover in this section. So here is the syllabus of AKTU Transportation Engineering of session 2019 and 20. So in this unit we will cover there is a two section of this unit. First one is highway material and another in design of the highway pavement. In highway materials, first we will discuss property of the subgrade. Subgrade means that is the portion, soil portions or the foundation of the road. Another material is aggregates and binding materials. Aggregates, that is the cross stones, and binding material is in bituminous or the cementous material. Next, various tests and specifications of the materials like soil, property of soils, types of soil, moisture content of the soils, etc., etc. And aggregate, size of the aggregate, angular properties of the aggregate, shape of the aggregates, and binding materials, softening points of the bitumen or the ductility of the bitumens, and all other tests or the specification of the materials. In another section, design of the highway pavement. So first, types of the pavement. What are the various types of the pavement? Designing factor of the pavement. Design of bituminous paving mix. Next, design of the flexible pavement by CBR method. And designing of the rigid pavement by Westergaard theory. Load and temperature stresses. What are the various types of the joints provided in the design of the rigid pavement, and design of the rigid pavement by IRC methods. Okay, so let's start. So in first lecture of this unit or this section, first we will cover about the pavement. Just what is pavement? Okay. So what is pavement? A pavement is the durable surface material laid down on an area intended to sustain vehicular loads or foot traffic, such as a road or the walkway. Or in simple way, we can say that highway pavement or road pavement is a structure which consisting of a superimposed layers whose primary function is to distribute the applied load or whatever the load act on the pavement, like the vehicle loads, which transmit or distribute to the subgrades. Okay. So types of pavement. What are the various types of the pavement? Basically, in the highway designing or the road constructions, there are two types of the road. One is flexible pavement and another is rigid pavement. Flexible pavement is also known as the bituminous pavement, since flexible pavement is made by bitumen, or the binding material used or a bituminous used as a binding material, or a black top pavement because the bituminous material or the bitumen, tar or coal color is black. Okay, so this type of the pavement or the flexible pavement also known as the black top pavement due to the color or the visibility or the okay. Another one is the rigid pavement or the CC cement concrete pavement because flexible pavement made by cement concrete, or the white surface due to the surface appearance, grayish color or the semi-white color, so it is also known as the white surface pavement. Okay, here is the comparison of the flexible pavement and rigid pavement. What are the texture, what is the function of structural, what are the structural difference between the flexible pavement and rigid pavement, and the functions and all other comparisons here. So first one is how have a low flexural strength. In flexible pavement or flexible pavement have very low flexural strength, very low or the negligible flexural strength, but in case of the rigid pavement have more flexural strength, since when the load is applied on the rigid pavement, so the whole load is distributed all over the surface, so the intensity of the load is decreased and decreased. But in case of the flexible pavement, the load is act on the pavement in a very small area, so the pavement is deformed under the heavy loading, and after passing of the load it may regain. So there is no flexural or the very low flexural strength in the flexible pavement, and in rigid pavement there is a flexural strength. Another point is the load is transferred by grain to grain contact, and in case of the rigid pavement no such phenomena. So transfer to by grain to grain means, suppose there is a load applied on the pavement, so the load exactly act in this position. Suppose load act in this position, so the grains or the substance which bear the load, it transfer the another grains which is contacted with each other. So this grains transfer another grain, and this grains another. So according to this phenomena, the load is distributed by grain to grain and finally to the subgrade of the soil or subgrade of the pavement. Okay, but in case of the rigid pavement there is no such phenomena because in rigid pavement the load is transferred by a slab action. Suppose a load is applied anywhere of the surface, or either at the center or edge or corner of the pavement surface, but the stress or the intensity of this load is distributed uniformly like a slab action. Okay, another one is surfacing cannot be laid directly on the subgrade, but a subbase is needed. But in case of the rigid pavement there is no subbase, because since flexible pavement transfer the load grain to grain, so the thickness of this type of pavement is need more, because to reduce the intensity before final load is transferred to the subgrade. But in case of the rigid pavement, since the load is distributed thoroughly the surface or the as a slab action, so there is no subbase needed. And another reason is flexible pavement is more pervious compared to the rigid pavement. So the water which percolate or seep through the surface is travel through the by the subbase, or subbase used as a drainage layer. Another is no thermal stresses are induced, and in case of the rigid pavement, thermal stresses are induced. In the bituminous pavement, the effect of temperature but in case of concrete pavement, CC pavement, since concrete having a property to expand or contract due to the temperature, so there is a thermal stresses are induced. If there is a high temperature, concrete may expand, so long extra expand, in this case of tension or the thermal stresses are induced. But in flexible pavement there is no such stresses are induced. Next one, expansion joints are not needed, and in case of the rigid pavement, expansion joints are needed. So due to the temperature variations, as we already just discussed about point number 4, that there is a thermal stresses are induced in case of the rigid pavement. So to maintain these stresses, there is a joints provided between the pavements in longitudinal as well as transverse joints. So because of the thermal stresses, concrete may expand or contract. If concrete, suppose there is a high temperature and concrete is expand, so there is a gap between the concreting. So if this section is expand or this section is expand, so then it may be free to expand, and there is no cracking developed. But suppose we do not provide such types of the joint, so the whole concrete length is too large since length of the road is, so the expansion due to the temperature variations, expansion of the concrete may crack the surface. So the joints are needed in case of rigid pavement. Expansion joint. Another one, design life of the rigid pavement is more compared to the design of the flexible pavement. So in case of the flexible pavement, the design life is generally 10 to 15 years, but in case of the rigid pavement, it is 20 to 30 years. Initial cost of the construction is very low in case of the flexible pavement, and initial construction cost is high in case of the rigid pavement, and the maintenance cost is high in case of the flexible pavement, but the maintenance cost is low in case of the rigid pavement. Another point is road can be used for the traffic within 24 hours, but in case of the rigid pavement, since rigid pavement is made by the cement concrete, which consists of the cementitious material or cement, so any type of the cementitious material or the cement or the concrete need to cure about 7 days, 14 days, 21 days or 28 days, what as for the functions of the concrete or the structures. So there is a minimum 14 days curing needed for the road surface, and until we cannot be used. The last one, damaged by oils and certain chemicals, but in case of the rigid pavement, no damage by oils or the other chemicals. Since the bituminous material or the bitumen is an emulsion which react or certain types of the chemicals or the oils, and due to the reaction of the emulsions or the bituminous and the oils or the certain chemicals, the binding properties or the binding of the aggregates becomes weak, and the aggregates start stripping due to the movement of the vehicles. But in case of the rigid pavement is a very impervious surface, so no such types of the chemicals or the ions react with the cement or the binding materials. Okay, so here is the pic of the rigid pavement. First one, we can clearly say in rigid pavement and flexible pavement, color of the rigid pavement is semi white, not perfectly white, but maybe it can say in compared to the flexible pavement is a white pavement, and this one is the black pavement due to the color of the bitumen. So one difference is there ki the color of rigid pavement is white, so it is also known as the white pavement, and the color of the flexible pavement black, and it is known as the black pavement. Here is another pic of flexible pavement and rigid pavement. Okay, requirements of the pavement. What are the various requirements? Suppose you are going to construct or you are going to design or construct a pavement, so what are the various points that you have to keep in mind while construction of the pavement? So first one is sufficient thickness to distribute the weight load stresses to save value on the subgrade soil. Okay, as we discussed in comparison, point number 2, the load is transferred by the grain to grain contact. So if you have to justify this point, so the thickness of pavement is too sufficient, so the wheel load or the vehicles that moves on the road surface is distributed safely to the subgrade, so the thickness is enough or the sufficient thickness. Okay, another structural is strong to withstand all types of the stress imposed upon it. All types of the stress mean the vehicular stress, the major stress or the major load, that is आपका wheel stresses. After that, in case of the rigid pavement, there is a thermal stresses also induced in case of the rigid pavement. So all what are the types of the pavements stresses imposed upon it can be strongly withstood without any types of the failure of pavement. Okay, another one is adequate coefficient of friction to prevent skidding of the vehicles. There is a contact between the tire and the road surface which allow the vehicle movement safely without skidding. So the pavement surface is too smooth or that there is no skidding of vehicles. Right. Another one is smooth surface to provide comfort to road users even at the high speed, and the surface is too smooth so that suppose a vehicles moving at a design speed, and the design speed of the road or a national highway suppose 80 km/h, if a car or a vehicles move at the design speed, so the vehicle or the passengers are traveling through the vehicles may feel comfort. Another one, produce least noise from moving vehicles. It is also an important parameter that the material what the materials you are going to use or in construction of the pavement should be least noise produce. Dust proof surface so the traffic safety is not impaired by reducing visibility. It is also important that the quality of the material should be so strong that there is no dust or the dirt raised due to the vehicle movement. Suppose you are using a very poor quality of the materials, so due to the abrasion of the vehicles, the material maybe break, or may it produce a dust. Due to this, the visibility affected. Next one is impervious surface, so that the subgrade soil is well protected is also important. Impervious surfaces may be contracted by the providing a proper camber and also the top surface material. So the water cannot allowed to enter in the pavement. And last one, long design life with low maintenance cost. It is the point of economy. Okay, here is some peak of load distribution. Okay, suppose first let's see this peak, because it's a distribution of pressure under single wheel load. Here look this peak, there is a load which act on this surface, but the thickness of the surface is too low, so the stresses act a very low contact area. The load is distributed very small contacted area, so the stresses induced very high. But in case of in this figure, in case of the sufficient thickness, the stresses are distributed in a large area, and due to the large area, the intensity of the load is reduced, and so it affects the pavement very low in compared to this. Okay, and in another pic we can see there is a distribution pressure produced by the multi-wheel assembly. Suppose there is a wheel, two wheels. Here is a two wheel, one and two, and it assembled in a single axle. Okay, so due to this wheel, suppose on left side, okay, this wheel, the load is distributed like this, and due to the right side wheels, load is distributed like this. So till some depth, the load pressure act individually, but after a depth, the stress distribution due to this load and stress distribution due to load is overlapping, and this phenomena is overlapping of load or stresses is known as the equivalent single wheel load systems. We will discuss ESWL, equivalent single wheel load system. We will discuss this topic later in design or design of the rigid pavement. Okay, not here. So next one, here is also a peak of load distribution. First one, rigid pavement. In rigid pavement, suppose look here, a rigid pavement. Suppose load is acted out at this place, but the stresses due to this or the pressure due to this load is distributed in a large area or the whole pavement. Okay. No doubt the maximum stresses will be developed just under the load, but the pressure distributed overall on the whole surface or the whole pavement. But in case of the rigid pavement, flexible pavement, suppose load is acted here, the intensity or the pressure distributed in a very small area, because the stresses is distributed through the grain to grain. Okay, in this situation the load contact is spread in a small area and the intensity induced very high. Yes. Due to this this type of the pavement is fail due to case of the heavy load, and the overall life cycle is low compared to the rigid pavement, and like in case of 10 to 15, but in case of 20 to 30 years. In case of the flexible pavement 10 to 15 years, but in case of the rigid pavement 20 to 30 years. Here are the types of the flexible pavement. This section we will discuss later in next week. Okay, so for today's the end of the today's lecture here. Okay, thank you, bye bye.